Okay, so what I want to examine in this video is something called average rate of change. Average rate of change is actually a pretty simple idea. A lot of times when you learn about slope, slope is this, if you have 2 points. Well, this is how fast the y's are changing with respect to how fast the x's are changing. So that right there is a rate of change. A lot of times you hear slope defined as a rate. Um, so if you have a straight line, then you always have that same rate. The x's always change at the same with respect to the y's at a particular value. So the slope never changes. Um, but if you have a curve and you want to know the slope between like these 2 points, then what you end up doing is you calculate a slope, but it's considered the average slope between these 2 points. Or an average rate of change. So the idea of average rate of change really just means what's the slope. If you graph f, in this case, that function, if you graph it, then you figure out, okay, where are the 2 points associated with 0 and pi, and you draw the secant line through them, and then you just find that slope. So let's do this problem. So if I'm looking for the average rate of change of this function, I'm going to work in radians, because basically everything we're going to do in calculus will be in radians. So if I graph this, let's see, cosine plus 2. So let's see, up 1, 2. And cosine starts 1 unit higher than that. So cosine t plus 2 is going to do this sort of thing. It's basically the cosine graph just moved up 2 units. And the low point is 1, the high point is 3. This is not an x-axis, it's actually a t-axis. And this is my y-axis, or f of t-axis. Or actually, I'll call this one y. And this will be f of t. And let's mark the important points. 0 is one of them. So this coordinate right here is 0. And even though I know it's 3, I'm going to say f of 0. And then I also have to find pi, which is going to be at the low point here. So this is pi, f of pi. And what I need is the slope of this line that goes through it. So average rate of change is the same thing as slope of the secant line. Secant because it cuts through more than once. And that's really going to be f of pi minus f of 0 all over pi minus 0. So it's y2 minus y1 over x2 minus x1. So f of pi is, if I plugged in pi, you can do this without even the graph because you could just plug in straight into this thing. So that's going to be 1. F of 0 was 3. And then I'm going to divide that by pi minus 0. And so I'm going to get negative 2 over pi. So that is my average rate of change from 0 to pi. Okay. The second one says from negative pi to pi. Negative pi is right here, and pi is right here. You can tell pretty quickly if I draw a secant line through those points, that slope's 0. So that one's actually a lot easier. This slope's just going to be 0. So average rate of change there, it doesn't change. It doesn't go up or down between those 2 points. Well, if you're only looking at those 2 points. So the average rate of change there is 0. Okay.